Okay, this video is going to cover our second tissue type, connective tissue. It has lots of different functions. It's a lot more specialized compared to epithelial tissue. So we're going to have 5 groups of connective tissue, and within those 5 groups, they all do something a little bit different. We're going to cover the first 2 types in this video. Connective tissue binds structures together, provides support and protection, fills spaces, produces blood cells, and stores fat. In general, the tissue cells are widely separated by a matrix, so there is other filling. When we were looking at epithelial tissues, it was like one layer of cells or more attached to a basement membrane with a free surface. So it was much more like layered, almost like a cake. When we're looking at connective tissue, it's a lot more unstructured, so the cells might not be as close together. The matrix just means there's other stuff, there's more filling. It can be solid, semi-solid, and there are some liquids. The matrix, or the filling, determines its properties. There are a couple different fibers that are going to be found within connective tissue, and depending how many of each fiber it has, it's going to determine its properties. So white fibers contain collagen, so they're very flexible and strong. Yellow fibers contain elastin. They're more elastic and not as strong, so more stretchy. Reticular fibers are thin and highly branched. They have collagen that provides support, but they're a lot more thin. So depending on which fiber is present and how many of each, it's going to determine the structure as well as the function of that connective tissue. So we'll see these fibers appearing in all different types of connective tissue. Here we have a joint, and you can see that there are so many different types of tissue found just in this one location, and they all have really different and highly specialized jobs. So you might say, how is bone and blood all the same tissue type? They're still connective tissue, they're just really specialized. Here are your 5 types. We're going to do 1 and 2 today. Fibrous and dense. In our next video, we'll look at cartilage, bone, and blood. So fibrous connective tissue has 3 different types: areolar, adipose, and reticular. They're all found in unique locations, and they each have a different job. So fibrous areolar tissue, I like to call this one the filler tissue. It's going to be found between organs. It binds them together. Might be found between body cavities, providing cushioning and support. Areolar tissue contains 3 things. It has these thicker collagen fibers, it has thin elastic fibers, and it has fibroblasts, which are these large star-shaped cells. It has lots of white fibers and some yellow fibers, so it's pretty strong and supportive. Think about it. If it's going to be taking up empty space in your body cavity and holding your organs in place, you want it to be flexible, right? So you can still move around, but you want it to hold your organs in place. You want to make sure that if you turn too fast to the left, your stomach's not dropping out of your body cavity, right? So it's supportive, holding stuff in place, but still flexible. So here, this is a real image of some areolar tissue. I can see those thick collagen, thin elastic. So here's the cartoon version. When we look at the real image, I see the thick collagen and these more kind of almost look like hairs, the elastic fiber. And then there's fibroblasts kind of dotted all the way around. So very different than epithelial tissue because it's not in a nice layer or a nice line. It's this matrix with cells sprinkled in between. Then we have adipose tissue. So this stores fat and provides insulation. So it's also a cushioning tissue, but it's storing energy as well. We have the little nucleus that's kind of smashed off to the side because most of the cell is getting taken up by the fat droplet. It's found lots of places beneath your skin, found around organs like the kidney and heart. It's important that it cushions them, found within breast tissue. So here is a look at some real adipose tissue. We can see that most of the cell is taken up by the fat. Some of these, it's really hard to see the nucleus. It's this darker thing that's pushed off to the side. You might think that this looks very familiar because it kind of looks like squamous tissue. We're going to keep this one separate from squamous because we don't see a nucleus. It's typically a lot more white and clear because it doesn't have cytoplasm, right? This fat stains differently compared to the cytoplasm. There's also no nucleus in the middle. If this was squamous tissue, each one of these cells would have a nucleus in the middle, but we only see them kind of pushed off to the side, getting moved out of the way by the fat droplet. So two very different functions. Go back to areolar, binding and cushioning. This one also provides cushion, but it's also providing that insulation and fat storage. So it's being supportive, but in a little bit of a different way. Our last type of fibrous tissue is reticular tissue. So it has reticular fibers, which is our third fiber. And it also can be referred to as lymphatic tissue because it's found in the lymph nodes. The spleen, the thymus, it's related to immune function, and it's responsible for storing and producing white blood cells. So if you had an immune cell for your specialized cell project, reticular tissue is responsible for helping it mature and develop into its specialized form. So you have reticular cells and that reticular fiber spread around through. It's holding onto these cells, letting them develop, and then sending them off to where they need to go in the body. In the past, students have said that images of this almost look like a cherry blossom tree because of the dark branching fibers and the cells spread out all over the tissue. When I look at this, I keep it separate from areolar tissue because I only see one type of fiber. I just see dark reticular fibers. When we compare it to, areolar tissue, I know areolar has collagen and elastin and fibroblasts. This one just has cells and one type of tissue, okay? It's also distinct because it has an immune function and the other two do not. Okay. Another type of connective tissue is dense connective tissue. And we call it dense because the fibers are a lot closer together. It forms kind of like seamless bands because they're all really close. Very different compared to fibrous, which is a lot more spread out. So we've got two types, regular or irregular, and they are named for what they look like, which is nice. Regular has parallel bundles of collagenous fibers, so they're nice and straight, more organized looking. It's found in tendons and ligaments. So it's really strong. It binds organs and joints together. Maybe you know that tendons attach muscle to bone and ligaments connect bone to bone. So you want a pretty strong, flexible, but still tough tissue that's holding your joints together. Irregular, similar fibers, but the bundles are very disorganized. They run in all kinds of different directions. It is the inner layer of the skin. So you have that outer epithelium. It's going to be anchored to this stuff. So it's a lot more flexible. It moves a lot of different directions, which is important, right? You want to be able to like move your skin around and flex it every which way without that tissue breaking. Compared to regular, which is strong, tough, because the bundles are parallel. They both have fibroblasts, but you guys will see that their structure looks completely different. Dense regular, lots of nice even lines. Fibroblasts are few and far in between. Dense irregular, I think it kind of almost looks like a fingerprint when it's blown up. That might help you remember that it's the inner layer of your skin. So dense irregular, kind of chaotic looking compared to regular. That is where we are going to pause for today. Let me go back real quick. So we went over the first two groups. I covered fibrous and dense. We talked about the structure of all 5 of these and how their functions are a little bit different. In the next video, I will cover cartilage, bone, and blood to wrap up connective tissue.